Good evening everyone. Today we will be discussing the topic of hybridization and geometry, that means how to find the shapes of the molecules. This is one of the very important topic in chemistry, because if you see previous year's questions from chemical bonding, actually we used to get many questions from this chapter. Okay, in the only NEET exam, chemical bonding is very important chapter. Now in that chapter most frequently questions come from hybridization topic or molecular orbital theory. This is another topic. From these two areas maximum number of questions had come in the previous years. In recent years also, in recent exam 2023 exam also, if you see, question came from molecular orbital theory but from chemical bonding. So and sometimes, actually many times in hybridization also question had been asked. Okay. Now first we will see generally what type of questions will come from this area. They will give either they give structures like this and ask what is the hybridization of the atoms. This is one model. Okay. Second model is they may give chemical formula. So this is structure. By giving structure, they may ask what is the hybridization of so and so atoms. Second model is what? By giving the chemical formula, they may ask you what is the hybridization. Third is what is the shape. They may give some formula and what is the molecular shape of this species. These are the three areas which you used to get from this topic. These three areas we will discuss today. Not very difficult, please concentrate. Okay, now first we will deal with this. This is very simple out of the three models. When they give the structure like this and ask what is the hybridization, it is very simple topic. But to answer such questions, you need to have idea on what is sigma bonds, what is pi bonds, and what are lone pairs. These three topics, these three concepts you should have idea. So first let's discuss them. Okay. Now see, what is sigma bond? So suppose if I have two atoms are there, let's say A, B. Now let's say it has a triple bond. Maximum you will see triple bond only, single bond or double bond or triple bond, not more than that. Now if triple bond is there, then one of the bond is sigma. What is sigma, what is actually pi, how sigma bond is created in the covalent bonding, these topics you will learn in the chemical bonding chapter formally. Okay. So now don't go into that topic, just understand that how to identify sigma and pi bonds if a structure is given. Now if three bonds are seen, then one will be sigma, other will be pi bonds. Similarly, suppose if A and B are joined by two covalent bonds, one will be sigma, other will be pi. Suppose if only one bond is there between them, that will be sigma only. So sigma is a must between two atoms in a covalent bonding molecules. Sigma is must. So after that you count how many bonds are there between them, that is the number of pi bonds. Okay. Now you know what is sigma, what is pi bonds. What is lone pairs? See, lone pairs means, suppose if I have A atom bonded to B, let's say. Now here A has, let's say, 3 pairs and B has 1 pair, let's say like this. Okay. Now what is the meaning here? A and B are bonded. When line is drawn, it is a covalent bond. So A and B are covalently bonded, and A has, there are some pairs which are not participating in any bond. How many pairs are not participating in any bond? On A, 3 pairs. In B, there is a 1 pair. Pair means 2 electrons. 1 pair of electrons on B which is not participating in the chemical bond. So these pair of electrons which are not participating in any covalent bond, not participating in neither sigma nor pi bonds, these are called lone pairs, and it is represented like this. So how many lone pairs are there in total in this molecule? B has 1, A has 3. A has 3 lone pairs, B has 1 lone pair. So total 4 lone pairs are present in this. Now this pair which is bonded between A and B, here there is a bond, and in every covalent bond 2 electrons must be involved. So here 2 electrons are involved in forming a covalent bond between A and B. So what about these electrons? These electrons are called bond pairs, not lone pairs. Lone pair means not participating in anything, it is alone. Bond pair means it is shared between the 2 atoms. So number of bond pairs, BPs I will write. BPs means bond pairs. In this molecule drawn, whatever molecule I have drawn, in this number of bond pairs are how many? 1 pair is there. See, this is a bond. And number of lone pairs, I will put like this, LPs, lone pairs. How many? 3 plus 1, 4 lone pairs. Now let us take one more example to first understand lone pairs, bond pairs. Okay, see, suppose now let us take a molecule. Let us take a molecule like this, okay. Or first simple one I will take hydrogen. Now if I ask you the questions, how many number of sigma bonds and how many number of pi bonds and number of bond pairs, PPs means bond pairs, number of lone pairs. Now let us look into the molecule. Now see here, if only single bond, covalent bond is there, that must be a sigma bond. So this is sigma, sigma, sigma. What about this carbon and carbon? Again single bond, so sigma bond. CH bond is also sigma. Now between carbon and oxygen there are 2 covalent bonds are there, and one must be called sigma, the rest of the things will be pi. So one I am putting sigma, other will be pi. Now total sigma bonds you count 1, 2, 3, 4, 4 sigma bonds are there, 5, 6, total 6 sigma bonds are there. Sometimes they may ask you how many sigma electrons, then what to do? Sigma electrons, suppose if I ask number of sigma electrons, total how many sigma bonds we got? 6, and in each bond how many electrons must be involved? I already mentioned in each covalent bond 2 electrons will be involved. So 6 sigma bonds, each one has 2, so 6 into 2, 12 electrons involved in sigma bonds. So total sigma electrons are 12. Now pi bonds, how many pi bonds are there? There is only 1 pi bond in this molecule. Suppose if I ask you how many pi electrons, then 1 pi bond, it has 2 electrons, so 1 into 2, 2 electrons. Pi electrons are 2. Now number of bond pairs. Now bond pairs means what? Sigma bond is also a bond only and pi bond is also a bond. So total pairs of electrons which are involving in bond you have to count. So how many bonds are there? Total six sigma bonds are there. That means 6 bond pairs are involved in the sigma bond formation. And in the pi bond, how many pi bonds? One pi bond is there, and in that also one pair of electron involved to form that pi bond. So total how many pairs? 6 sigma pairs and one pi pair. Total 7 pairs of electrons. 7 bond pairs are present in this. Okay, just you count number of bonds, sigma plus pi total you count, that is the number of bond pairs. Total bonds if you count you are getting 7. Number of lone pairs. Number of lone pairs means which are alone, which are not participating in the bond. That is how many? See, carbon has no lone pair. Hydrogen also has no lone pair, but oxygen has, see, one pair here, one pair here. Total 2 lone pairs present on the oxygen. This is how you have to identify sigma, pi and lone pairs. Now let's understand how to find hybridization using this concept. Okay. Now hybridization from structure. See, if structure is before you, that means how many bonds are there between two atoms. If clearly visible to you in a structure, then how to find hybridization? Then see, calculate sigma. Hybridization we will calculate from sigma plus lone pairs. Sigma plus lone pairs around any atom you count sigma, how many sigma bonds are there and how many lone pairs are there around it. If that value is, suppose, 2, if that value is 2, then that hybridization is called sp hybridization. S1 P1, 1 plus 1 2, like that you remember. If sigma plus lone pairs, I will show you with an example, but first understand, if sigma plus lone pairs value is 2 for a given atom, then atom's hybridization is what? Sp. Suppose if it is 3, then the hybridization will be sp2. See, 1 plus 2, 3. This is the hybridization. Suppose if it is 4, then S is 1, then P should be how much, so that you will get 4? P should be 3. 1 plus 3, 4. So sp3 we call it. Now, suppose if it is 5, don't write sp4. Why can't, sir? See, because in quantum numbers topic we have seen, in a p subshell only 3 orbitals will be there, not more than that. So here p4 is not technically possible. Then what to take, sir? S1, p3, next go for the D. So 1 plus 3 plus 1, total 5. Next 6. If 6 is there, then S1, P3, D2, then only 1 plus 3 plus 2, you will get 6. 7, sp3, D3. These are the main hybridizations which you come across. There are some other hybridizations also, like dsp2. These hybridizations you will get in the coordination complexes chapter of second year. Okay, but in chemical bonding generally we will encounter this 6 types of hybridizations. Okay, now let's take an example and find this hybridization. See, suppose CH I have taken a molecule like this. Now I want hybridization of these circled carbons. What is the hybridization of the circled carbons? Okay. Now, so first we will find H value. Depending upon that, we can tell what is its hybridization. H value is very simple. See, H is number of sigma bonds around this atom plus lone pairs. Is there any lone pairs present on this carbon? No. All the four, actually carbon is tetravalent. 4 bonds only it can form, all 4 are over. So there is no lone pairs present on carbon. As you see in the structure also clearly, there are no lone pairs present here. So how many sigma bonds around this carbon? 1. This is pi bond, so we don't need it. Sigma, sigma. So sigma bonds will be 3. See, 1, 2, 3. There are no lone pairs on this carbon. So 3. 3 means which hybridization? sp2. So this carbon is sp2. Next, this carbon. How many sigma bonds around it? 3 sigma bonds are there. 1 pi bond. We don't need this. 3 sigma bonds. So therefore, H will be 3. Lone pairs are nothing. So this is also sp2 hybridization, this carbon. Now let's take this one. This one, how many sigma? Again here also around it, if you count, there are only 3 sigma bonds are there and no lone pairs. So again it is also sp2. So like this you have to find from the structure. Let's take few more examples and get more clarity on this. Okay. See, suppose if I have a structure like this. Now in this structure, see what is first understand, let's understand what is the meaning of this structure, then only we can find the hybridization. Okay. So we have to find hybridization of oxygen and carbons, all carbons whatever is there, we have to find hybridization. See, normally suppose if I take CH3, CH3, we know that it is called ethane. Now in line bond formula we just write like this. This is called line bond representation. In this representation we don't mention the carbons, we don't mention the carbons, we don't mention the hydrogens attached to the carbons. So see here hydrogens, 6 hydrogens are attached to carbons, so we don't mention it, represent it. 2 carbons also we don't represent. But this line indicates these terminals are what? Terminals are carbons, and to satisfy tetravalency of carbon, each carbon should be attached to the 3 hydrogens, because already 1 bond is there, the other 3 bonds has to be with the hydrogens. This is called line bond representation. Similarly, let's take another example. Suppose CH3, CH2, CH3, like this is there. Now how many carbons are there? 3 carbons are there. So if I put one line, this will represent 1 plus 1, 2 carbons only, but I need one more carbon. So to show that we will put one line at some angle. So this is 1 carbon, this is another carbon, this is 3rd carbon. Like this we have to interpret. Now this carbon has how many bonds? One bond is shown, the other 3 bonds has to be with the hydrogen. This here 2 bonds are there around this carbon. So to satisfy tetravalency 2 more bonds we require. That's why the other two with the hydrogen. And last third carbon, only one bond is there visible, 3 are missing. So to satisfy tetravalency, those 3 must be with the which element? Hydrogen. So like this, okay. One more we see, suppose if I have CH3, CH double bond, CH2. So here how to write line bond representation? Just draw like this. So this is one atom, one carbon, this is second carbon, this is third carbon, 3 carbons. And this carbon has how many bonds attached to hydrogen? One is already there with carbon, the other 3 with hydrogen. This carbon has already visible 3 bonds are there. See 1, 1, 1, 3 bonds. Only one bond is not shown, that must be with the hydrogen. See, this is one hydrogen attached, and this one, this carbon has how many bonds visible? 2 are visible. The 2 which are not drawn here must be with the hydrogen. To satisfy tetravalency of carbon, 4 must be there, 2 are already there, the other 2 must be with the hydrogens. So this is called line bond representation, which you will learn again in the organic chemistry in the beginning of organic. Okay, now see here first let's write the full molecule with all the hydrogens, then only we can count number of sigma bonds and lone pairs. Okay, see here hydrogen is not attached to the carbon, that's why it is represented. The hydrogens which are attached to the carbons are never represented in this representation. Okay, now let's draw this properly. Oxygen attached to hydrogen, there are 2 lone pairs on oxygen. Now this oxygen is attached to this is what? This is carbon, this is carbon, this is carbon. Okay, so carbon, next one more carbon, last carbon. Now carbon is tetravalent, so 4 bonds has to be there, but only how many bonds are there? 2 bonds are there. So 2 are missing, that must be with the hydrogens. Let's draw them. Here carbon has how many bonds? 3 bonds are there, so 1 is missing, it must be with hydrogen. This carbon has only 2 bonds, so 2 are missing. Okay, now this is the full structure. Okay, now let's first put sigma and then find the hybridization. See what are the sigma bonds here? How many? This is sigma bond, this is sigma, this is sigma. Now other bond has to be pi. Okay, now first let's go to the oxygen and find its hybridization. H is equal to, we know sigma plus lone pairs. Once we count that, we will get what hybridization this oxygen involved. So sigma bonds, how many around this oxygen? 2. Here this is sigma, this is sigma. How many lone pairs are there in oxygen? 2 lone pairs. So we got 4. 4 means, if you remember the earlier page, S1P3, then only 1 plus 3 is 4, right? So sp3 hybridization, oxygen is sp3. Now let's take the second element here, carbon. So sigma bonds, no lone pairs, but how many sigma bonds total? 4. So H value will be 4. So here also sp3. What about this carbon? Sigma lone pairs are 0, sigma bonds are 3. So sp2. Now what about the last carbon? 3 sigma bonds, no lone pairs. So therefore this is also sp2. This is the way you have to follow. Okay. Let's take one more molecule, benzene. Let's similarly find its hybridization, benzene. Now say benzene structure you must have seen. something like this. Again, here what are these points? These are points where carbon is present. So how many total carbons? 6 carbons. Now at each carbon, if you see, only 3 bonds are there around it. 1 bond is missing at every carbon. But to satisfy tetravalency of carbon, that missing bond is with what element? Hydrogen. So let's attach this is called benzene. This is benzene. Okay, now let's see, all are similar carbons, there is no difference. See, every carbon has around it 4 bonds are there, 1 pi bond is there, 3 sigma bonds are there, and every carbon is similar only. Now take any carbon and find the hybridization, that will be same for every carbon in the benzene. So count how many sigma, 1, 2, 3, this is pi bond, so H is 3 plus 0, that means sp2 hybridization. Every carbon in benzene is sp3 hybridization. Okay. Now let's take another molecule, xenon, XeO3, xenon structure. Now in this structure, let's find the hybridization of the element xenon. So how to find? Again, how many sigma bonds are there around it? 1 lone pair is there, it is visible here. Let's find the sigma bonds. So H value is, see, count sigma bonds 3, lone pairs are 1, that means hybridization is sp3. S1p3 we don't call, it is understandable, sp3. Okay. So that is how we have to find hybridization from the structure. If structure is given, very simple, but without actually putting pen on paper, we just count the sigma bonds and lone pairs and we can tell the hybridization. Next. This is very important. How to find hybridization if structure is not given, but chemical formula is given, like CO3 minus 2, SF4, XeO3. In earlier, when they give structure of XeO3, we counted number of lone pairs and sigma bond and answered the question. But suppose if they give XeO3 without giving structure, then how do we know number of sigma bonds and number of lone pairs? Okay. So chemical formula when it is given, how to find hybridization. Now, see here H, how to find H, because if you know H value, we can find hybridization. If H is 4, sp3, if H is 5, sp3d, like that. Now how to find this? Remember this formula, half of okay. Here H value if it is 2, you will get sp3, sp2 likewise. Now here what are the other alphabets? What is V, what is M, what is C and A? Now look here, VC. VC means number of valence electrons on central atom. Central atom means what? There is an atom at the center and surrounding some atoms are joined to this one. So, okay, some atoms are joined to the central one. We call this one as central atom. Okay, we have to find the hybridization of the central atom. So, valence electrons, how many are there? We have to count. I will tell you a shortcut how to find. Next, monovalent, this MS. MS means what? Number of monovalent surrounding atoms. Monovalent surrounding atoms. So monovalent means what? If an element forms single bond, that is called monovalent. Double bond divalent. 4 bonds tetravalent. Carbon is tetravalent. Okay. Oxygen is divalent. Like that, how many bonds it is forming? That is what the valency. How many bonds it can form with the hydrogen or halogens? That is the valency. Okay. Monovalent means single bond it should form. What are those elements? Just remember, what are the monovalent surrounding atoms we will encounter? One is hydrogen and halogens. Halogens means what? Fluorine, chlorine, bromine, iodine. So these halogens or hydrogens, if they are present in the surrounding position, understand that they are monovalent surrounding atoms. Okay. Next, C. Here C and A are there. What is C? C is magnitude of cationic charge. A means magnitude of anionic charge. Okay. See, what is magnitude? Magnitude means number. For example, minus 20 if I give you, in that minus is a sign, whereas 20 is a number. So here minus 20, what is magnitude if I ask? 20 is the magnitude. Plus 30, what is the magnitude? 30, just number. Okay. So suppose if charge is minus 3, magnitude is 3. So that is how we have to substitute here. So if there is a cation, if chemical formula given to you is a cation, substitute the cation magnitude here, anion place will be 0. If given ion is a anion magnitude you substitute and cation will be 0 in that case. If suppose given molecule is neither cation nor anion, then cation place also 0, anion place also 0, because it is a neutral molecule. So like that. Now, how to find number of valence electrons? One proper way is write electronic configuration and count the number of valence electrons. But that takes time consuming process, and some of you may not be knowing at this stage how to write the electronic configuration also. So leave that. That is the formal way. But there is another shortcut is there which will save your time. That is, suppose in periodic table there are 18 groups are there. Okay. Suppose if I take group 1, in group 1, what are the elements? Lithium, sodium, potassium, rubidium, cesium. Group 2, beryllium. I am not going to write a whole periodic table, don't worry. Only few I am writing: beryllium, magnesium, calcium, strontium, barium. D block I am skipping. Now P block, group 13, boron, aluminium, gallium, indium, thallium. I am not writing them right now because I am focusing on most commonly seen elements only right now. Next, group 14, carbon, silicon, germanium, tin, lead. Group 15, nitrogen, phosphorus, arsenic, antimony, bismuth. Group 16, oxygen, sulfur, selenium, tellurium, polonium. Group 17. Group 17 is for the halogens: fluorine, chlorine, bromine, iodine. And group 18. Group 18 is noble gases. So Here what will come? Neon after fluorine. Of course, helium is also there, but after fluorine I am writing neon, argon, krypton, xenon, radon. Radon is a radioactive. Okay. Now, if you this much if you can figure out, okay, if an element is given to you and if you can identify which group number it will fall, then valence electrons will be very easy. For example, if suppose if they give any of these elements, okay, sodium, potassium, rubidium, any of these, and they ask how many valence electrons, answer is 1. So I am writing here valence electrons. Here answer valence electrons is 1. Here valence electrons if I ask you 2. And here valence electrons don't say 13, okay, but say take this number. How many valence electrons? 3, 4, 5, 6, halogens 7, 8 noble gases. So without writing electronic configuration and worrying about it, you can simply, if you can identify which group it will fall under, you can easily get the valence electrons. Okay. Now keep this in mind. Now we will take one example and find and apply the formula written in the previous slide and identify the hybridization. Okay. Now see, suppose if I take CO3 minus 2. If I ask you what is hybridization of central atom. Normally hybridization is for the central atom only, not for the surrounding atoms. Now what is the hybridization of the central atom? What is the central here? Carbon is there, the other 3 oxygens connected to carbon. So if this is carbon and the other 3 oxygens are connected to this carbon. So central one is what? Carbon. So indirectly hybridization of carbon they are asking. Okay. Now in this species, in this ion, let us find the H value. H value on what? Central atom. Central atom in this case is what? Carbon. Okay. So carbon is the central atom. Half of valence electrons of carbon only we want, central atom only we want, plus monovalent surrounding atoms, and this is anion, not a cation. So cationic place will be 0, anionic place will be 2, magnitude is here 2. So minus cation plus anion. Anion means you have to add electrons, cation means you have to subtract electrons. It is not a cation, so subtraction value is 0, it is an anion, so you have to add 2 electrons there because minus 2 is there. Okay. So now see, half of, in the earlier slide we have seen carbon belongs to which group? Group 14. So number of valence electrons are 4. Surrounding atoms are how many surrounding atoms? 3 surrounding atoms because 3 oxygens are around the carbon. So number of surrounding atoms are 3, but we don't want number of total surrounding atoms. We want monovalent surrounding only we want. So these 3 oxygens, we have seen monovalent surrounding means what we have to look for? Hydrogen or halogens. So oxygen it does not fit into that category. So there is no monovalent surrounding atoms around the carbon. So 0 and plus 2. So 4 plus 2, 6, 6 by 2, 3. So if H value is 3, what is the hybridization? S1P2, sp2. So hybridization of carbon is sp2 here. Okay. Let's take another example. Now this time we will take XeO3. XeO3 we have done previous list from the structure. So what hybridization we got in XeO3? See, XeO3 what hybridization we got? sp3. From structure we got this. Now we will take formula, not the structure, and let's figure out, are we getting sp3 or different one? Okay. Now XeO3, it is neither cation nor anion. So cationic place also 0 in the formula, anionic place is also 0 in the formula. Okay. Now what is central atom? Central atom is what? Xenon. So xenon is a noble gas. If you see that list previously, it is in the group 18. Group 18 means how many valence electrons? 8. So H is equal half of valence electrons of central atom, means xenon here, plus monovalent surrounding atoms, and it is neither cation nor anion, so both will be 0. Now xenon, since belongs to group 18, valence electrons will be how many? 8. And monovalent surrounding, again oxygens are there as surrounding atoms, and oxygen is not a monovalent, hydrogen or halogens only we have to consider. So monovalent surroundings are 0. So 8 by 2, 8 by 2 means 4, 4 means what? sp3. See, we got the same answer like that of structure. So this is how you have to identify the hybridization. Okay, let's take few more examples. Let's understand this thoroughly. Suppose this time let's take SF4. In SF4, what is the central sulfur? Around that sulfur, 4 fluorines are connected. So central atom is sulfur. So for that central atom, we have to find the hybridization, because hybridizations are defined for only central atoms. Now H is equal half of valence electrons on the sulfur, that is the central atom, and monovalent surrounding atoms. To avoid S, I will write V sulfur. This is surrounding. Neither cation nor anion, so 0 and 0. Now, sulfur belong to which group? Oxygen, sulfur. So we have written in which group? Group 16. So valence electrons are how many? 6. Now, how many surrounding atoms are there? 4 fluorines. Are they monovalent? Yes. Halogens and hydrogens are monovalent. So these all 4 fluorines are monovalent surrounding atoms only. So 10 by 2. 10 by 2 means 5. 5 means what hybridization? sp3d. Because if you add how much you are getting? 1 plus 3 plus 1, 5. sp3d. Okay, so hybridization of sulfur in SF4 is sp3d. Next. Now, we will take one more example. XeOF4. Now here you will get first one confusion. Sir, here three elements are there: xenon, oxygen and fluorine. Which one we have to take central atom? Which are the surrounding atoms? Now remember, if multiple atoms are there and you are in confusion, generally take the less electronegative atom as the central atom. Less electronegative atom as the central atom. Okay. Sir, what is electronegativity? We don't know about that concept. Now, as of now, don't worry about that. You will learn that in the periodic properties chapter. But now remember one thing, fluorine, F is the highest electronegative element in the periodic table. Second place is for the oxygen. Okay. These rest all are below that only. Remember only these 2 points. Fluorine is the highest, oxygen is the second highest electronegative. So, in this given 3 elements, which is the lowest electronegative element? Then xenon, because fluorine is highest, oxygen is second. So, what is the remaining? Xenon. So, that should be taken as the central atom in general. Okay. But don't follow this strictly in every case. If multiple elements are before you, more than 2 elements are there, if you have confusion what to take as central, follow this, because sometimes it will fail also. For example, if I have H2O, here don't say, sir, oxygen is second highest, you said electronegative, hydrogen must be low electronegative, I will take hydrogen as central atom. It is not correct here. Here, as it is clearly visible who is central and who is surrounding it, oxygen is central, hydrogens are connected to this oxygen. It is clearly visible from the formula, which is the central. So, don't apply this unnecessarily, that rule. If multiple elements are there only, follow that. Okay. Now, so we know that xenon is central, and to that xenon one oxygen is connected and 4 fluorines are connected. Now, what is the hybridization of that central atom? Xenon. Okay. Now, half of valence electrons in xenon, monovalent surrounding atoms. It is also not a cation nor anion. So, cation place, anion place will be 0. Okay. Now, xenon noble gas, so present in which group? Group 18. So, valence electrons are 8. Valence electrons are 8. Monovalent surrounding atoms. Now, here, if I ask you how many total surrounding atoms, 1 oxygen and 4 fluorines, total surrounding atoms are 5. But are these all 5 atoms monovalent? No. Monovalent means what? See here, out of these 5 surrounding atoms, only 4 halogens are there. Fluorine is a halogen, only 4. And halogens and hydrogens are only monovalent. Oxygen is not monovalent. So, you should not take 5 here, because 5 is the total number of surrounding atoms, but we have to take monovalent surrounding. So, what we have to take here? 4. Now, 8 plus 4, 12. 12 by 2, 6. 6 means what hybridization? Yes, P3, add 1 plus 3, 4. We need 2 more, D2. So, sp3, D2 is the hybridization. Okay. I hope you understand this. Now, let us go to the shapes. Molecular shape, which is also called molecular geometry. How to find this? See, to understand these shapes, again, you need to have some knowledge of the shapes. Okay. Now, suppose if I take hybridization, sp hybridization. Hybridization is what? sp. Now, in sp hybridization, suppose here in sp hybridization always the shape will be what? Electron geometry and shape, molecular shape or molecular geometry. Molecular geometry is also called shape of molecule or sometimes called structure of molecule, same. Now, suppose if I take A and B, these two are connected like this, and hybridization, sorry, one more B I will take, and hybridization of the central element A is SP. Then it is called linear. What is its name? Linear. Similarly, molecular geometry is also called linear. What is the difference between electron geometry and molecular geometry? Understand it. Suppose here there is no difference. SP hybridization wise, if you see, you don't find any difference between them. When you go to the next hybridization, I will explain. You will clearly see the difference between molecular geometry and the electron geometry. Now, sp2. Now in sp2 means we know that number of sigma bonds plus lone pairs value has to be 3. Sigma plus lone pairs is 3 has to be there, then only sp2. Sigma bonds plus lone pairs. Now let's take first one case where all 3 are sigma bonds, 0 lone pairs and 3 sigma bonds. First we will take this case 1. Case 1 is what? 3 sigma bonds, 0 lone pairs. We will take after that case 2. Case 2, 2 sigma bonds, 1 lone pair. Then also if you add, you will get 3 only. Next, case 3, 1 sigma bond, 3 lone pairs is a rare case. I have not come across in my experience. So let's forget about that. These two cases we will see. Okay, case 1. How many sigma bonds? 3 sigma bonds, 0 lone pairs. So let's put that. Three sigma bonds. Case 2, 2 sigma bonds, 1 lone pair. So let's put sigma bonds. See, these surrounding atoms need not be same, they can be different also. A is connected to B one side, A is connected to C also, D also, it does not matter here. I am taking similar surroundings. And here this is not, there is no element here, lone pair is there. Okay. Now electron geometry. Electron geometry means, see here if you join these elements, if you visualize and join them, you will get a triangle, equilateral triangle, and this triangle always will be in single plane. Any triangle you take, you can put it in a plane. So it is called trigonal planar. Trigonal planar is the electron geometry. Electron geometry as well as molecular geometry is also trigonal planar only. Okay. Now when you come to this one, case 2, here if you look at the electron pairs, bond pairs plus lone pairs, this is also visible like a triangle. This lone pair and this bond pairs, total if you together if you visualize, you will see a triangle. So here trigonal planar is the geometry of which, if you take all the electrons, so it is called electron geometry. Okay, now listen carefully. But if you take only bond pairs, not the lone pairs, now remove that lone pair from your picture. Okay, forget about it. Now only visualize the bonds. How many bonds are there? 2 bonds. One is this bond, other is this. 2 bonds only present. Now these 2 bonds, if you see, then the shape is like what? It's like a V shape, or if you reverse way, if you see V shape or bent shape, it is also called angular shape. Only if you visualize bond pairs, see this is one bond, this is one bond, then you will get a shape called bent shape, also called V shape, also called angular shape. Now this is called molecular geometry or molecular shape. Mostly they will ask questions on shape or molecular shapes, molecular geometry. Okay, rarely you will get question on electron geometry. So molecular geometry is bent or V or angular. Electron geometry means don't just take the bonds, you have to take the lone pairs also into your picture and see what shape it is coming. Okay, so electron geometry wise trigonal planar. Here there are no lone pairs, everything is present, only bond pairs only present, because case 1 has 0 lone pairs. Since everything is bond pair, here electron geometry is also trigonal planar, and molecular geometry means only bonds you have to consider, that is also trigonal planar. Okay, like this electron geometry means consider lone pairs and bond pairs together and see the shape, and molecular geometry means only bond pairs you have to visualize before you and see the shape. This is SP, SP2. So SP has linear always. SP2 has 2 cases. One is trigonal planar molecular shape, other one is angular or V shape or bent shape. Okay, when one lone pair is there, bent shape. 0 lone pairs are there, shape will be trigonal planar. Keep that in mind. This will help in solving problems afterwards. Next. Now SP2 is over, let's take SP3. In SP3, sigma plus lone pairs must be equal to what? 4. Then only SP3 hybridization we will get. Okay, what are the possibilities here? Case 1, 3 sigma, 4 sigma and 0 lone pairs. Then 4 plus 0, 4. Case 2, 3 sigma, 1 lone pair. 3 plus 1, 4. Case 3, 2 sigma, 2 lone pairs. 2 plus 2, 4. 1 sigma, 3 lone pairs, again rare case, I have not seen such molecule. So these are the 3 cases we will encounter. Now let's take case 1. Now in case 1, 4 sigma bonds should be there, no lone pairs on the central atom. So let's take A, 4 sigma bonds if you put like this, 0 lone pairs. B. Now its shape is, if you join these 3 B's, you will get a triangle here. Bottom will be a triangular base. Okay. Now join this B to the above one. So you will get a pyramid. A triangular base is there and above B is there. If you join all the corners of the base to this above B, you will get a pyramid. Okay. Now this pyramid is called, in this pyramid, every side, every edge has a same length. Okay, every edge has a same length, and this is called, this pyramid is called tetrahedral. Okay. Sir, what is this tetrahedral? Is it electron geometry or molecular geometry? Both, because there are no lone pairs here. Okay. So if there are no lone pairs, then all electrons are involved in the bond pairs only. So electron geometry is also tetrahedral. Molecular geometry means only bonds we will take, that is also tetrahedral. Electron geometry and molecular geometry, both are tetrahedral only. Now let us take the case 2. So case 2 has how many sigma unlone pairs? 3 sigma, 1 lone pair. So 3 sigma bonds should be there. So let's draw out of 4, 3 are sigma bonds. That means on the other side of the bond there is a one element is there, then only bond will be there between them. But here don't put B, because this should not be a bond pair. So I'll write a like this, which represents there is a pair here. Okay, don't call this line as a bond anymore. Okay, this is not a bond because this side element is not there. So this is not a bond, just lone pair, one lone pair is there. Like that only you read it. Okay, now 3 sigma bonds and 1 lone pair. What is the electron geometry? Electron geometry means you have to take all lone pairs and 3 bond pairs total. So electron geometry, and electron geometry is what? Tetrahedral. Okay. Now shape will be what? Shape will be, say if you join this, now see shape, in order to tell the shape you have to visualize only bond pairs, not the lone pairs. So forget about this. Now only if you look at this picture, you will see this one as this is also a pyramid. A is there and 3 B's are there. So if you join 3 B's with A, you will get a pyramid. But this is called a trigonal pyramidal, or simply it is called pyramidal. This pyramid and this pyramid, what is the difference? In this pyramid all sides are same length, but here if you look at this, see this length is different from this length, because this is BB, this is AB. Different elements involved means the distance between them also will be different. So this shape is not called tetrahedral. This is called trigonal pyramidal. Molecular shape or molecular geometry is trigonal pyramidal, simply called pyramidal. You need not use the word trigonal here, simply you can say shape is pyramidal. Okay. Now lastly, case 3, 2 sigma bonds and 2 lone pairs. So let's write one lone pair and the lone pair, only 2 sigma bonds. So if you look at only bond pairs, okay, if you look at only bond pairs, then what is the bond pairs here? Only bond pairs, if you look, it is like a V shape or angular shape. Okay, so this is one bond, this is another bond. So molecular geometry is V shape or bent shape or angular shape. Okay, and electron geometry will be, again you will consider all the pairs, and electron geometry we will say tetrahedral. Okay, so sp3 has 3 types of molecular shapes, that is tetrahedral, pyramidal, third one is angular or V shape. If 0 lone pair is tetrahedral, 1 lone pair shape name is pyramidal, 2 lone pairs V shape. Next, sp3d. In sp3d, what should be the H value? H value should be 5. Then only 1 plus 3 plus 1 will be 5. Now here, case 1, 5 sigma bonds, 0 lone pairs. Case 2, 4 sigma bonds, 1 lone pair. Case 3, 3 sigma bonds, 2 lone pairs. Two sigma bonds, 3 lone pairs. These are the different cases you will encounter. Okay. Now here I am not going into the shapes and confuse you. Okay. Anyway, you will learn this topic again. Don't worry, in the hybridization topic of chemical bonding, you will learn this again. Now I will just write the names. Earlier we have seen in sp3 0 lone pairs tetrahedral, 1 lone pair pyramidal or trigonal pyramidal, 2 lone pairs if they are there. In sp3 hybridization case it is angular or bent. Same way we will just write the shape names. Okay. 0 lone pairs, what will be the shape name? 1 lone pair, 2 lone pairs, 3 lone pairs. That is sufficient to to answer such questions. We need not draw and see what is the scenario. Okay. So let's say here 5 sigma 0 lone pairs. 0 lone pairs, if it is there, then the shape name, I am just focusing on the molecular geometry names. Molecular geometry. Now here 0 lone pairs, if it is there, it is called trigonal bipyramidal. Trigonal bipyramidal. 1 lone pair, if it is there, instead of 0 lone pairs, if 1 lone pair is present, then it is name of the shape is seesaw. 2 lone pairs, it is T shape. Lastly 3 lone pairs, linear. Okay. So these are the 4 shapes. See, sp2 hybridization, 2 shapes we have seen. sp2, 0 lone pairs trigonal planar, 1 lone pair V shape. In sp3, 3 variations, 3 different shapes we have seen in sp3. Tetrahedral and V shape we have seen, pyramidal. Now in sp3d, 4 variations we have seen. Trigonal bipyramidal, seesaw, T and linear. Okay. Next, let's take the sp3d2. Okay, sp3d3 is very rare case. We need not go into that. sp3d2 also we will see and we will solve problems. sp3d2. So in sp3d2, again here sigma plus lone pairs has to be what? 1 plus 3 plus 2, 6. It has to be 6 now. So 6 sigma bonds can be there and 0 lone pairs, 5 sigma bonds, 1 lone pair, 4 sigma bonds, 2 lone pairs. Normally we will see up to here. Okay. 3 sigma bond 3 sigma bonds, 3 lone pairs case is very rare. We have not seen that. So this much you remember. Now first thing, molecular geometry name is what? First one, when there are 0 lone pairs, it is square bipyramidal. It is also called octahedral. 1 lone pair if it is there, it is just square Bi will not be there, only pyramidal. Okay, why these names are there? When we draw the structures, you will come to know. Anyway, that you will see formal in chemical bonding chapter. When we see square and joined upside pyramid and downside pyramid, we call it square pyramidal, square bipyramidal. If only pyramid is one direction, not in other direction, we call it square pyramidal. So when you draw the structures, you will see the names. But as of now, just remember these names. Two lone pairs. If two lone pairs are there, it is called square planar. That's it. Okay, sp3d3 is not that important. So I will revise this again and then we will go to the problems. So in SP only I will focus on shapes only, molecular shapes. So in SP only one type of shape exists, linear. Okay, leave it. SP2, two types exist. One is trigonal planar when zero lone pairs. When one lone pair is there, V or angular shape. Next, leave it. SP3 hybridization. Three variations are there, three shapes. If zero lone pairs tetrahedral, one lone pair pyramidal, two lone pairs V shape or angular or bent. Leave it. SP3D. SP3D hybridization has how many variations? 4. If zero lone pairs trigonal bipyramidal, if one lone pair seesaw, two lone pairs T shape and three lone pairs linear shape. Okay. And lastly, SP3D2 hybridization, here three variations, square pyramidal if zero lone pairs, one lone pair square pyramidal, square bipyramidal and square pyramidal, two lone pairs square planar. Square is coming in all three, easy to remember. Okay. Now, using this knowledge, let's find the shape of the molecules. But to find shape of the molecules, we know how to find H value. Half of V plus M formula we can use to find the H value. Okay. Now, once we know H value, hybridization we will know. But only with hybridization we cannot tell the name of the shape. Suppose hybridization is sp3. Is it sufficient to tell the name of the shape? No. Because sp3 may have tetrahedral, it may have pyramidal, it may have V shape. So, by just knowing the hybridization we cannot tell the shape. We need to know the number of lone pairs also. If number of lone pairs and hybridization both are known, then we can pinpoint what is the shape of that molecule or species. Okay. Now, what is the formula finding lone pairs on central atom? How to find lone pairs on central atom? So, very simple. Number of lone pairs is equal value of hybridization minus surrounding atoms. Total surrounding atoms, not just monovalent, all surrounding you have to subtract. Okay. First, let's do this one problem, then we will get idea. For example, if I take CO3 minus 2, earlier we have calculated the hybridization of carbon, that we will get 3. sp2 hybridization we have concluded that time. Okay. Now, if I ask you how many lone pairs on the central atom carbon, number of lone pairs on central atom only. Here central atom is carbon. How many lone pairs are there? Formula is what? Hybridization minus total surrounding atoms. Hybridization is what? Carbon hybridization value is 3 minus number of total surrounding. How many total surrounding? 3 oxygens. Yes, those are not monovalent, but we don't bother here. All surrounding we have to take. So, no lone pairs present on the carbon here. Okay. So, hybridization 3 means sp2 hybridization. In sp2, lone pairs are nothing. So, what will be the shape of this molecule or molecular shape? trigonal planar. Okay. So let's take few more. Suppose if I have XeO2F2. Okay. Now I will need to find the shape of this molecule. How to find? So here which is the central atom? Less electronegative out of all is xenon. So that is the central atom. So let's find H value. H is equal half of group 18 element xenon is. So valence electrons are 8. Number of surrounding atoms which are monovalent. Oxygen is not monovalent. Halogens are. How many are such things? 2. Neither cation nor anion. That is it. So 10 by 2 means what? 5. 5 means what is the hybridization? sp3d. Okay, we got hybridization. Now sp3d has 4 variations: seesaw, T shape, like that. 4 variations are there. Now we need to find which one it is, which shape it is. For that lone pairs we want. So let's find lone pairs. Number of lone pairs on the xenon. Formula is what? H minus total surrounding atoms. H value is 5. Total surrounding atoms how many? All surrounding you take. How many? 4. So 1 lone pair. So 1 lone pair sp3d hybridization. So what will be the shape? What will be the name? See, sp3d hybridization has 4 variations. 4 shape names are there. Now we got in our case 1 lone pair. 1 lone pair means this case. So what should be the corresponding shape? Seesaw. So therefore 1 lone pair sp3d hybridization. So shape of this molecule is seesaw. Okay. Let's take one more and then we will close this. XeF4. So again xenon is central atom. All fluorines are monovalent atoms only. So 12 by 2, 6. 6 means sp3d2. Now lone pairs. 6 minus how many surrounding atoms total? 4. So 2 lone pairs in sp3d2 hybridization. What is the shape name? See, sp3d2, 2 lone pairs. So shape name is what? Square planar. So shape is square planar. Suppose if you take carbon dioxide. What is central atom? Carbon. Carbon is group 14 element. So 4 valence electrons. These are not monovalent atoms. So 4 by 2 means which hybridization? sp hybridization. sp hybridization you need not calculate lone pairs because it has only one shape, that is linear. So CO2 carbon dioxide is a linear molecule. So that's it. So like this is very important topic and not difficult. See how to find hybridization and how to find shape. If you remember only this much in this 1.5 hour class, whatever you have learned, with this you can answer almost all questions related to this. Okay. Yes, few doubts you will be having. What is sp, sir? S is a s orbital, p orbital. Sp means what actually? Okay. and what is actually difference between sigma bond and pi bond, what is the actual sigma and pi means. These basic questions will be answered when we enter into the chemical bonding topic. When teacher teaches you, he will explain what is sigma, pi, etc. But regarding name of the shape and hybridization, this much is sufficient to answer all these questions. I hope you understand this topic and revise this as well. Okay, thank you very much. ఉన్న క్లాస్ అవుతుందా ఇప్పుడు ఉందా